Hey, physics guys. We have that problem that we did in class. I'm going to go over it one more time. This way we can go through it. You can go through it a little bit slower because you'll have a video that goes with it. Of course, we're going to use these two formulas that we were talking about earlier. These are our constant acceleration formula. And when we're talking about free fall, we are definitely talking about constant acceleration, right? Because the acceleration due to gravity, negative 9.8 meters a second squared, doesn't change, right? The gravity on Earth is the same all over the Earth. Doesn't matter if you're up at Mount Everest or way out up in the upper atmosphere. It's still going to be just about 9.8 meters a second squared. So let's go ahead and just use that and know that that's our constant acceleration. So I've rewritten our constant acceleration formulas to look for the two things that we're trying to find in this question. And what was our question today? It was a ball is thrown upward at 59 meters a second. When does it reach, what time does it reach its highest point? How many seconds, right? And then the second part is, how high did that ball go, right? So we're going to look for a distance measurement or a displacement measurement, right? So the first one is looking for time. So I'm going to use this formula here, but I'm also going to talk about the things that we should know. What are we given, right? So the initial velocity is given to us. Sorry, I'm out of the frame, but you don't need to see my ugly mug. Our initial velocity is 59 meters a second. So I'll write it in here, 59 meters a second. Now, when that object gets to its highest point, right? I throw this marker in the air, it goes up and then comes down, right? Well, but when it reaches its max height here, it comes to a stop and then starts coming down. So it stops at its highest point. Therefore, its velocity at that highest point is 0 meters a second. There we go. Now, what are we looking for? We are looking for time in seconds. All right, well, let's use our formula. Our formula is V final minus V initial divided by our acceleration. So T is equal to our final velocity, which is 0, minus our initial velocity, which is 59 meters a second. So 0 meters a second minus 59 meters a second divided by the acceleration due to gravity, which is 9.8, negative 9.8 meters a second squared. And one of those questions we had on our sheet when we were working on those questions today is, how do we decide whether gravity is going to be negative or positive, right? Well, we said that if we throw something upward and it comes down, we have two different directions that the object is traveling. We're going to call up positive and down negative. We could switch it around. Everything would work out exactly the same. But for our purposes here, upward is positive, downward is negative. So 0 minus 59 is negative 59 meters a second. Now, negative 9.8 meters a second squared. This next part is very, very important in physics class. We need to look at the units and see what we can cancel, right? I have a meters on top and a meters on top. I can cancel that out. I have a seconds here. Well, I have two of them, right? Because it's seconds squared. So I'm just going to cancel out that square. And my answer is going to be in seconds. Is time listed in seconds? You betcha. So we are well on our way. So we've canceled our units. Now all we have to do is the math. Well, the math says, and I did it just a second earlier. 59, negative 59 divided by negative 9.8 is positive, positive 6.02 seconds, but really and truly, we're going to call it 6 seconds. Why do I list it as 6? Well, I take a look at my least precise measurement, and my least precise measurement is in whole numbers, right? That's my 59 meters a second. Could I have listed it as 6.0 seconds? Yeah, but that's a little too precise for us. We in physics use our least precise measurement to figure out how we're going to list our answer. So if you gave me 6.0, I'd say it's okay. If you gave me 6.02, it's a little too precise for physics class. I would remind you to not make it quite as precise. But there we go. Our time is 6 seconds. Why is that important? Well, we need to know how long it's going to take to get up to the top. This could help us out later on if we wanted to use a different formula to find out how far it went. But we have another equation that tells us how high it went. We can just use formula number 2. Could we have used number 3, x final equals x initial plus VIT plus 1/2 AT squared? Yeah, absolutely. And we would come up with the same answer. We'd still come up with our 177 6/10. But I digress. Let's go ahead and talk about our 178 in a different way. Wow, there's the bell. It's so late. Anyway, let's start putting our information in. What do we have? We have a final velocity squared is 0 meters a second squared, minus our initial velocity squared, which is 59 meters per second squared. And I need to write it like this before I start doing any work. We're going to do just a little bit of extra work here. Divided by 2 times our acceleration, right? 2 times our acceleration, which is the acceleration due to gravity, which is negative 9 8/10 meters a second squared, right? Now, here's a big, important idea. 0 squared is 0 minus 59 squared, which is 3,481. Ooh, 81. There we go. 81. Now, I also square these units. So it would be meters squared over seconds squared. This is really important because it's going to help us to cancel units later. 2 times negative 9.8 meters a second squared is just negative 19 6/10 meters a second squared. Now, I have meters squared and meters, so I can cancel out a meter here and the squared there. That leaves me with meters. I can cancel out seconds squared with seconds squared. They're both exactly the same. So what am I left with? I am left with meters. Is that a unit for distance or displacement? You betcha. So we're on the right track. Now, 3,481 divided by 19.6 is, and they're both negatives, so we divide and we get 177 6/10 meters. Now, if we look at the data we've been given, our least precise measurement is here at 59 meters a second. It wasn't measured in tenths. So I want to list a whole number. So I'm going to say that this value is just about 178 meters, right? I have to go with my least precise measurement. So I'm going to say it's just about 178 meters, round to the nearest meter. That's it. That's our 2 answers that we got out of this problem. And you guys should be doing great. Thank you for your time, and I'll see you next time.